back to the Math and Physics Resource Center from Saginaw Valley State University. My name is Amanda, and today I'm going to be continuing on the previous lesson of evaluating a definite integral using antiderivatives. So similar to the previous lesson, antiderivatives are pretty much the opposite of derivatives, and when you use them to solve an integral within some specified bounds, so from some a to b, of some function, it's going to be the antiderivative of the function solved out for b minus the antiderivative of the function solved for a. And that's going to give you the value of the integral using the antiderivatives. I also showed how to find the antiderivative using polynomials. In this case, we're going to be doing it for trigonometric functions. So the derivatives of the trigonometric functions are the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent x is secant squared x. The derivative of cosecant x, which is just 1 over sine x, is negative cosecant x times cotangent x. The derivative of secant x, which is just 1 over cosine x, is secant x tangent x. And lastly, the derivative of cotangent x is negative cosecant squared x. So what this means, now that we know the derivatives, we know that the antiderivative of cosine x is sine x. The antiderivative of cosine x is sine x. The antiderivative of negative sine x is cosine x, which would mean that the antiderivative of positive sine x is negative cosine x. Again, it's just the backwards derivatives. So now let's look at an example. An integral from pi to 3 pi over 2 of negative cosine x dx. So we know that the integral, the antiderivative of cosine x is sine x, but it's negative. But we know that the derivative of sine x is a positive cosine x. Therefore, if we made it a negative sine x, the derivative would be a negative cosine x. So that means the antiderivative of negative cosine x is going to be negative sine x. And if you want to check if you did it right, just take the derivative of what you took. Because if you take the derivative of sine x, you're going to get negative sine x, you're going to get negative cosine x, which is a good check to know that you got it. So now we're going to evaluate it at 3 pi over 2 and pi. So we're going to have negative sine of 3 pi over 2. That's going to be minus negative sine of pi. And that's going to be negative sine of 3 pi over 2. Using our unit circle, we know that's going to be negative 1, so negative 1. And that'll be minus, a lot of negatives, minus sine of pi, which according to our unit circle is 0. So our final answer is going to be positive 1. Thank you so much for visiting the Math and Physics Resource Center from Saginaw Valley State University.